T-minus 30 seconds.
At launch, the International Space Station will be 260 miles in altitude, flying south of Nuremberg, Germany.
Stage 1, pressing for flight. 15 seconds.
All right, here we go.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engines full power. And liftoff of crs-26. Go Falcon and happy Thanksgiving ISS.
That's right, liftoff of SpaceX's Falcon 9 rocket for the 26th cargo resupply mission, bringing new science experiments and solar arrays to the International Space Station.
Falcon 9 carrying crs-26 on its way to the International Space Station. We are throttling down the engines on the first stage, and this helps us prepare for max Q, which is maximum dynamic pressure. It's the largest structural load that the vehicle sees on ascent, and we should be passing through that period. In a few seconds here. That call out that we passed through max Q. Great views there of Falcon 9 carrying NASA's crs-26 mission. We are coming up on a few events happening back to back. That's going to be MECO, or main engine cutoff, as the first event. That's where all 9 of the M1D engines shut down on that first stage, all 9 of those engines that you see lit up on your screen there. And that's in preparation for the next event, which is stage separation. That's where the first and second stage separate. The first stage will flip around and make its way back down to Earth and land on our drone ship named Just Read the Instructions, while the second stage ignites its Merlin MVAC engine to boost Dragon to low Earth orbit during SES-1, or second stage engine start 1. And the last event is the boost back burn to reduce the velocity of the first stage in preparation for atmospheric re-entry. And that whole sequence takes about 30 seconds, and we are coming up on those few events happening here in a few seconds.
And MECO. Stage separation confirmed. Stage 1 boost back startup.
Stage 2 ignition.
Some really cool views there. We had MECO, stage separation, the MVAC engine lighting up on your right-hand screen. We also saw the first stage kind of in the view of the second stage view there, falling back to Earth, doing a flip, and now in its boost back burn. Now that burn lasts about 30 seconds long.
Stage 1 boost back shutdown.
And there's that call out, and the boost back burn has shut down on the first stage. That is the left-hand screen. That's a view of the first stage there. On your right-hand screen, a view from the second stage looking at our MVAC engine. And you can see on your screen, on your left-hand screen, the grid fins are deploying on that first stage. Very cool views. You're watching a live webcast for the 26th commercial resupply mission to the International Space Station for NASA. This is SpaceX's 54th mission for 2022 and the 5th Dragon flight to the International Space Station just this year. Now, we lifted off just about 4 minutes ago from Kennedy Space Center at Launch Complex 39A. And so far, both vehicles on nominal trajectories. Again, on your left-hand screen is a view from the first stage. On your right-hand screen, an awesome view of the second stage MVAC engine with the Earth in the background. For the first stage, in order to make its way back to our drone ship, again, just read the instructions. It has a couple more burns to execute. The first is the entry burn. That's where 3 of the Merlin engines reignite. This helps to slow the stage down as it re-enters the upper parts of the Earth's. Great call-outs there. This entry burn helps to slow the vehicle down as it re-enters the upper part of the Earth's atmosphere. Now, the second burn is the final burn for the first stage. It is called the landing burn, and this is a single engine burn that brings the vehicle's speed down rapidly in order to touch down on the drone ship. Now, you may see some bursts of gas on your left-hand screen. That is nitrogen gas burst for attitude control. And then again, you could see the grid fins. You could see 2 of the 4 grid fins on the first stage. These are hypersonic grid fins positioned near the top of the first stage. So once it's in the atmosphere, stage 1 only uses the grid fins to steer as it makes its way back down to Earth.
Stage 1.
Now they orient the rocket. They orient the rocket during re-entry and guide the rocket.
Stage 1 entry burn
descent.
startup.
That call out. Now you can see on your left-hand screen the entry burn has begun on the first stage.
Shut down.
And there you can see those engines shut down. That concludes the entry burn for the first stage. Again, next up will be the landing burn for that first stage vehicle in just about 30 seconds or so. Stage 2 is still looking good on your right-hand screen. Again, a view from the Falcon 9 second stage looking at the MVAC engine. About 20 seconds away from that landing burn beginning on the first stage. Again, this is a single engine, the center E9 engine burn to help slow the vehicle down just enough to touch down on the drone ship.
Stage 1 landing
just
burn.
Read the instructions today. And you can see that the landing burn has begun on the first stage. Let's watch as Falcon 9 touches down on just read the instructions.
Landing leg deploy.
Really awesome
Stage 1
views
landing
there. Falcon 9 has touched down. As you can see, it's standing tall on just read the instructions there on your screen. Now, while this Falcon 9 just completed its first flight, it marks the 153rd successful landing for an orbital class rocket. Now, next up, we do have SECO 1 on the second stage. That's where the Merlin vacuum engine will shut down. And SECO 1, or second stage engine
Stage 2
cutoff
FTS
1,
is saved.
will be coming up here in just under 20 seconds. Incredible view there with the Earth in the background.
SECO.
And there we heard the call out for SECO and watched as that MVAC engine shut down. And great call out there. That means we have confirmation of a good orbit for the second stage, still carrying the Dragon vehicle. Now we are T plus 9 minutes into the mission. Coming up on the last major task for Stage 2, commanding separation of Dragon a couple minutes from now. Now we expect to have live video of Dragon separation from the top of the Falcon 9 second stage, which looks into the trunk of the Dragon vehicle. crs-26 will be joining the Crew 5 vehicle currently on orbit, so we'll be back to having 2 Dragon spacecraft docked at the space station. As for cargo, today we will be delivering more than 7,700 pounds of science, research, crew supplies, and vehicle hardware to the orbital laboratory and its crew. And to date, SpaceX has sent and brought back over 250,000 pounds of crew and cargo to and from the International Space Station. The Dragon separation is just under a couple minutes away. And we should be able to get a live view of that. Some fun facts about Dragon. Dragon has 16 Draco engines, which have about 90 pounds of thrust each. But there are no Super Dracos on this vehicle, no seats, no life support systems, and that saves weight and space for faster refurbishment time, because this is a Dragon cargo vehicle versus a crew vehicle. Dragon also has fixed solar arrays on the trunk. The dark side is covered in solar arrays, and the light side is a radiator to cool the spacecraft. The Dragon can autonomously dock using its navigation sensors and centerline camera. And we are just about a minute away from Dragon separation. Again, if you're just now joining us, you are watching a live webcast for the crs-26 mission for NASA. This is the 26th commercial resupply mission to the International Space Station for NASA. This is SpaceX's 54th mission this year and 5th Dragon flight to station for 2022. And we lifted off just under 12 minutes ago from Kennedy Space Center at Launch Complex 39A. And we are just a few seconds away from Dragon separation from Falcon 9's second stage. You are looking at a live view into the trunk of the Dragon vehicle.
Dragon separation confirmed. Dragon separation
and
confirmed.
As you can see there on your screen and hearing those callouts as well, Dragon is drifting away from Falcon 9's second stage. Incredible view there. The next milestone coming up is the nose cone opening sequence. This protects the docking ring and navigation sensors. And that's going to do it for me here in Hawthorne, so I'm going to send it over to Sandra in Houston. How's it going over there, Sandra?
Hey, thanks, Jesse. Beautiful launch, as always. Great to see that. And, of course, welcome back into the International Space Station Flight Control Room here in Texas. We are standing by for confirmation of that nose cone deploy. That's the next major milestone that we are tracking today. Now, the nose cone does cover the docking hardware, which will be critical tomorrow during docking operations, but also navigation and rendezvous sensors, as well as the 4 forward bulkhead Dracos. Once open, the nose cone will stay open until the end of the mission, but will be reopened just after the deorbit burn and prior to re-entry. As we look ahead to nose cone opening, it is a process that involves opening the hard capture hooks with 6 non-nose cone hooks opening and then 6 nose cone hooks opening. And I did hear that that process has now begun. Again, we are in the process of the nose cone beginning to open. These are the same 12 hooks that will hold Dragon in place after it docks with the International Space Station tomorrow. And following the hook opening, the nose cone is deployed with motors. So we are continuing to stand by for the nose cone to open. This process can take a few minutes as all of those hooks do have to open. Once the nose cone is open, the team will have a process where each of the 4 forward bulkhead thrusters perform short impulse firings to check them out and make sure everything is performing as expected. Second set of hooks now opening. Additional steps will also take place once the nose cone is open, and that includes the spacecraft thermal control system, which will automatically be configured after the nose cone deploy sequence has started. The SpaceX team will also configure the systems on the trunk for operations. And this includes performing a health check on the solar arrays, which are wrapped around 1/2 of the trunk. And following that will be some communication reconfiguration with the team just to verify they're receiving telemetry through TDRS. That is the network of satellites that we utilize to communicate with the International Space Station. And then the final group of tasks after Dragon is on orbit, which of course it now is. We are standing by for that nose cone deployment, and opening is to check out the guidance, navigation, and control system. This will involve verifying the rendezvous plan and taking into account the initial orbital parameters, as well as looking at the targeted rendezvous burns that will be needed as Dragon approaches the International Space Station. There will also be a checkout of Dragon's star trackers and Dragon Eye. And we are hearing that all of the hooks are opening, standing by for confirmation of a good nose cone deployment. And we are beginning to get a view as the nose cone does open. Prior to this, each of the 6 hooks opened up, and now we are continuing to get these views as the nose cone opens. Once open, the nose cone, the Dragon docking hardware will be exposed. And the nose cone will remain open throughout the remainder of the flight. Continuing to get views of the nose cone opening. And we are standing by to hear a good nose cone opening.